welcome to the Deep Dive. Today, we're jumping into something really interesting from the world of competitive maths, the International Mathematical Olympiad, the IMO.
That's right.
You might have seen the news about Vietnam's performance in 2025, especially on problem 2.
Oh yeah, that was pretty remarkable. A perfect score, 42 out of 42 from the whole team.
Exactly. And what makes it, extra intriguing is that problem 2, which is often a geometry question, maybe medium difficulty, it was actually written by a Vietnamese teacher, Tran Quang Hung. So that naturally leads us to the big question for this deep dive. Is there really such a thing as a home problem advantage when a country's own proposed problem gets selected for the IMO?
It's a great question. It really gets into the nitty-gritty of competitive dynamics, doesn't it? Looking for those subtle edges.
It does. Are these tiny factors actually swaying, results in something as, pure as maths? So we're going to dig into the sources, look at the history, the stats, and see what we find.
Yeah, let's unpack it.
Okay, so 2025 sparks the question, but what about before that? Is there a pattern? Our sources suggest there might be, particularly looking at Vietnam's own history.
Right. There are a few key instances that stand out.
Like back in 1977, they also had problem 2 accepted, another geometry one, easy to medium, and their team scored, I think the source said, near max points on it. A definite boost.
Yeah, that seems pretty clear-cut.
But then, fast forward to 1982, Vietnam authored problem 6. Now, P6, that's typically one of the really hard ones.
The hardest, usually.
Right. And in that case, the advantage seemed to vanish. No clear boost for them on that problem.
Interesting. So difficulty matters.
Seems so. Because then look at 1987. Problem 4 this time, so maybe medium difficulty again.
Yep, middle of the pack difficulty-wise.
And there, a strong boost was visible. The Vietnamese team got something like 95% of the max points on their problem, compared to only, 69% on the other problems they attempted.
That's a significant difference.
And then we circle back to 2025, problem 2 again, easy medium, and that perfect 100% score.
So if you pull back and look at the trend, it really seems focused on those earlier, easier problems. Problems 1, 2, maybe 3.
That's what the data suggests.
Yeah, the home team often scores, say, 15 to 25% higher on their problem in those slots compared to how they do on the other problems in that same year.
Okay.
But when you get to the harder slots, problems 5 and 6, that effect really seems to fade out, or sometimes it even flips, like that 1982 example.
Why, though? What's actually happening there? Why would an advantage exist, especially for those slightly easier problems?
Well, there are a couple of likely mechanisms. One is just sheer familiarity. Teams train on hundreds, maybe thousands of problems. There's a higher chance they've seen variants or similar styles to the one their country submitted.
Especially in geometry, you mentioned.
Exactly. Geometry problems often have sort of authorial fingerprints, recognizable tricks or setups. Even if it's subconscious, that familiarity can help.
Okay.
And then there's a role of the team leader. They know which problem ideas were submitted by their country to the problem selection committee.
Ah, right. Not the final problem itself, but the initial proposal.
Precisely. So while they absolutely cannot reveal the shortlisted problem, that would be a major breach of confidentiality, and they sign NDAs, they can guide training. They can focus practice on analogous concepts or similar types of problems, knowing it's relevant without actually giving the game away.
I see. So it's about targeted practice based on knowing the kind of problem submitted.
Kind of, yeah. It provides a subtle steer.
Okay, that makes sense for the Vietnam examples. But does this hold up more broadly, like if we look at all countries over recent years?
It does, actually. The sources point to a statistical analysis covering 2000 to 2024. It looked at all the instances where a country had a problem on the paper and fielded a full team.
And what did that find?
It found that in 59% of those cases, the team scored 80% or more of the points on their country's problem.
Okay, and how does that compare?
Well, they only hit that 80% mark on other problems 39% of the time, so quite a difference.
Wow, is that difference statistically significant, like not just random chance?
Yeah, highly significant. The chance of that happening randomly is very low, about 0.013, so roughly a 1.3% probability. It's just noise.
Okay, that's compelling. Does it actually affect their overall rank?
It seems to have a small to moderate effect there, too. In 46% of the years where a team had a home problem, their overall rank improved by 2 or more places compared to their recent average. Compared to only 28% of the time when they didn't have a home problem on the paper. So, again, a noticeable bump.
So we're talking maybe an extra medal or 2 for the team, potentially?
Roughly, yeah. That seems to be the scale of the effect. It's not massive, but it's measurable.
Right. So if this effect is real, even if modest. What does the IMO do to try and, level the playing field? Are there safeguards?
Oh, definitely. The IMO regulations are quite clear on trying to ensure fairness. For instance, the country actually hosting the Olympiad in a given year isn't allowed to submit any problems at all.
Ah, okay, so the host is excluded.
Yep, and all the other participating countries are limited. They can only submit up to 6 proposals each year.
Got it.
Then, all those proposals go into a confidential shortlisting process. The team leaders who see this shortlist have to sign non-disclosure agreements. They're explicitly required to declare if any of the potential problems seem familiar to their team's training.
So there are rules and checks in place.
Absolutely. But the thing is, despite these measures, you can't completely eliminate that subtle familiarity, the stylistic fingerprints, or the possibility of that guided practice we talked about.
So it seems like a small advantage might just be inherent in the system, even with the rules.
It appears that way. It's a delicate balance.
So thinking about this for you, the listener, what does all this tell us? It shows that even in fields like high-level mathematics, where you expect pure objectivity, these subtle human factors and systemic nuances can still creep in and have an impact.
Exactly. The key takeaway seems to be that, yes, a modest home problem advantage is likely real. It doesn't guarantee success, and it matters the most on those easier or medium problems, not so much the really tough ones.
It's not about cheating, but more about familiarity and focus.
Precisely. And it leaves us with a final thought, perhaps. Looking ahead, should the IMO try even harder with more reforms to completely stamp out this effect? Or is this kind of small, statistically detectable edge just an acceptable, almost unavoidable part of the character of such a complex international competition?
Something to think about. That's all we have time for on this deep dive.
Thanks for tuning in.